Hey guys, I just wanted to record a lesson for you because we're doing TSI testing this week and I know that a lot of you are missing class, so I'm making a video to make sure that all of you get all of the material this week. So what we're going to talk about is reciprocal versus inverse trig functions. Is there a difference? How do we talk about those things? So here we go. So reciprocal functions are cosecant, secant, and cotangent. So it's the reciprocal. It's the numerator and denominator have switched places. So instead of sine over 1, it's now 1 over sine, or cosecant. And we can also talk about this in terms of r over y, or r over x, or x over y. So we've talked about all of those things. So those are all reciprocal functions. And then our inverse functions are inverse cosine, inverse sine, inverse tangent. We can also call those arcsine, or arccosine, arcsine, or arctangent. And so that's just, instead of finding the ratio, these are all angle measures. So the inverse all equal that theta, or the angle measure. So that's kind of the difference between reciprocal and inverse. So when we start to look at the graphs, we'll look at the reciprocal functions first. So as you can tell, this is a graph of sine, because it goes through 0 and ends at 2 pi, so there's no translations on it. It's just normal regular sine. So that's the red one. The orange one is the reciprocal. And what we can see here, so when sine equals 0, cosecant is the reciprocal of that. So instead of 0 over 1, now it's 1 over 0, which we know to be undefined. So every single time there's a 0 on my sine graph, so here, all of those, there's an undefined, which when we talked about tangent, it came up, okay, and so that means that there's an asymptote. And everywhere that there's a 1 or a negative 1 on my sine graph, so sine equals 1 or sine equals negative 1, every single one of those places, cosecant is going to equal 1, or cosecant is going to equal negative 1. So that point is the same on both the cosecant graph and the sine graph. It's the same. And so there's also going to be an asymptote here that kind of breaks up those graphs. But that's not as important as the vertical asymptotes here. So cosecant is kind of the opposite looking graph from sine, and so that's kind of what that picture looks like. But the two major points are the 1 values and the 0 values for sine and cosecant. And so when we look at cosine and secant, we can see exactly the same thing. So stop the video and take a second to mark in your asymptotes and mark in the coordinates that match on cosine and secant. Okay, so stop the video. And then moving right along, okay, so here's what your graph should look like. And the other thing I just thought about was you may want to color code your graph. So there should be some markers or colored pencils in my classroom or wherever you're watching this. So you may want to color code those so that you know that this is secant and that this is cosine. So these are both reciprocal functions. Okay. Then when we look down at our tangent versus cotangent, it looks a little bit crazy here because tangent also had some asymptotes. So when tangent is 0, every single one of those is going to create an asymptote for your cotangent graph. Every time tangent is 0, it creates an asymptote for your cotangent graph. Every time cotangent is 0, so this one, it creates an asymptote for that one. And it kind of looks dizzy a little bit. Okay, so the green is your tangent, and the black is your cotangent. So the other thing that's kind of interesting about this is where they are equivalent. And you may remember from the last couple of slides, it makes sense that where those two values are equivalent is going to be where tangent of x equals 1 and cotangent also equals 1, because the reciprocal is the same. And it also works for plus and minus for both things. Okay, so those are all reciprocal functions. Now let's talk about our inverse functions. Okay, so what does it mean to be an inverse function? So inverse means that the y and the x change places in the equation. So normal sine is y equals sine of x. Okay, we've talked about that lots of times. But if we switch the x and the y, now it looks like this. And so to get it back to y equals, so we can type it in the calculator or type it in Desmos, we have to do the inverse to this. So to do the inverse, this is inverse sine of both sides of the equation. Okay, and this is what we're doing when we solve for the angle measure. When we are doing inverse sine on the unit circle, when we were doing inverse tangent on quadrant trig, all of that was inverse of what we were, inverse trig functions. So what this ends up being, these two cancel, and that gives us y all by itself. And then on the other side, it's now sine, inverse sine of x. So if y equals inverse sine of x, it's like the x and the y have switched places, because now this is the ratio and this is the angle measure. But whereas before, this was the ratio and this was the angle measure. Okay, so that's what that means.